at higher order derivatives and product rule today. So higher order derivatives is simply just taking the derivative over and over and over again. So I'll show you a couple of applications to this in just a second once we learn how to do this. But this is some notation. So the first derivative, we've seen this. The second derivative, if I do the derivative again, here's our notation, and then third and fourth, and we could do this as many times as we're asked to do. But it's really an easy process. You just simply keep doing the derivative. So on this first example, example number 1 right here, I'm given x to the third as my function, and they want me to take the 1, 2, 3, third derivative. So I'm just going to simply start with a first derivative. Same rule that we've been doing. So x to the third, the derivative of that, bring the 3 in front, drop the power by 1, so 3x squared. So that's the first derivative. I want to get to the third, so I do it again. So second derivative, I'm going to look at this one, and I'm going to take the derivative of that first derivative. So 2 times 3, that gets me 6, and then I have x, because I dropped the power by 1. And now, take the third derivative. The derivative of 6x, simply just 6. The x has a power of 0, so it's gone. On this one right here, we're going to take the derivative of this right here. So we've got the first derivative already. We want to get to the fourth derivative. So first derivative, the way that we're going to notate this, it's already there. Second derivative, sorry, is what I mean. I'm taking the second derivative. So the way that we notate it is like this. Derivative of 5x to the fourth is 20x to the third. The derivative of 3x is just 3, so we have minus 3. We want to get to the fourth derivative, so we do it again. So now those 2's turn into 3's, because we're on the third derivative. The derivative of 20x to the third, bring the 3, multiply, so we get 60, drop the power, and we are at squared. Derivative of a constant is 0, so it's gone. And now the fourth derivative. So now these 3's turn to 4's. We are on the fourth derivative. Derivative of 60x squared. Bring the 2 in front to multiply. We get 120. Drop the power by 1 and we get x. So there is a fourth derivative. Next one is the derivative of sine x. We are on the original because I just have y equals. We need to get to the fourth. So first derivative. Derivative of sine is cosine. Second derivative. And then we have to be careful of our signs here. So the derivative of cosine is negative sine. Third derivative, 1, 2, 3. The derivative of sine is cosine, so we now have a negative in front of that with cosine. And now this is where I'm talking we need to be careful of those signs. Fourth derivative. We already have a negative. The derivative of cosine is negative sine. So I have negative times a negative, and that equals a positive sign. So we're back to what we began at with our fourth derivative. So some applications of these higher order derivatives are the acceleration problems that we're going to get to eventually. We've talked about position and velocity, and their relationship is the first derivative. But if I'm asked acceleration, it is the second derivative of position. So if I do position and one derivative, I'm at velocity. If I'm at velocity and I do one more derivative, I'm at acceleration. So this progression right here, whether it's forwards or backwards all year long, is something that we need. And I've put some just common notation for that on these for you to have. This example right here, the position of a particle is given by the equation right here. This is a position. Find the acceleration of the particle. So I start with position, I need to get to acceleration. So that is 2 levels down that I have to do. So I need the second derivative here. So first derivative from x of t, that's my velocity. So first derivative gets me to velocity. So 4t to the third, 4 times 3 is 12, t squared is what I have. Then negative 3t squared, we get negative 6t. 5t, that's simply just 5, and the constant's gone. So here's my velocity function. If I'm asked anything about velocity, here it is. But they want the acceleration equation, so I have to go one more derivative down. So starting at velocity, one more derivative, and I've got 24t right here. I've got negative 6 here, the constant's gone. So we have an acceleration function. But go back and look at what they asked. Find the acceleration for the particle when t is 3. So I actually have one more step. Now that I have acceleration, I want it at a certain time. So a at 3 is what I want. So 24 times 3 minus 6. And that gets me 66. Next up, we're going to look at one more example application of this. The velocity of a particle is given in the table below. So this is velocity. Determine the acceleration of the particle. So I need to think, what is the relationship between velocity and acceleration? Well, that's one derivative down. But what I want you to remember is that derivative is telling me that I need to think about slope. So acceleration is simply just the slope of velocity. So I have a table. I don't have a function to actually find the derivative of, but I can definitely find the slope, which is the same thing as finding a derivative. So at t equals 5, well, that's going to have to be an average right there. So these 2 points right here are what I'm going to work with. So I'm simply just going to do slope, y minus y over x minus x. So I've got 16 minus 10 over 6 minus 4. Simplify. We've got 6 over 2, which gets me 3. Now we're going to look at how to use the product rule for finding derivatives. So product rule basically is when I have two different functions multiplied together. So the first function is going to be called f of x, the second is f of g. So in this one, I've got, this is my f of x, and this is my g of x. And I might have just said that wrong. If I misspoke, I'm sorry. So when we want to take the derivative of two different functions being multiplied, we have a rule that we can do. And the way that we follow this is we take the derivative of the first, leave the second one, plus leave the first one, take the derivative of the second. So let me show you how to do this. So derivative of the first. Well, the derivative of x squared is just 2x. Then we leave the second one alone. Plus, we come back and leave the first one alone and take the derivative of the second. Well, the derivative of the second has two things going on. So what is the derivative of 2x? Well, that's simply just 2. And the derivative of a constant is 0. It's gone. So this is what I'm left with. If I want to make this look nicer, I absolutely can distribute and get 4x squared minus 4x. And then I've got x squared times 2, so that's 2x squared. Combine like terms, and we've got 6x squared minus 4x. And that is your derivative using product rule. So identifying those two functions is key. So this one right here, f of x is that 3x squared. My g of x in this case is the sine x. And now just follow the rule. So to find the derivative, take the derivative of the first. 3x squared, the derivative would be, or 3x to the third, sorry, would be 9x squared. Leave the second one alone. Plus, I'm running into this, so I'm just going to write it underneath. Leave the first one alone, 3x to the third. Take the derivative of the second. Well, the derivative of sine is cosine. And then there's really not anything that I can do with those because those are not like terms, so I'm going to leave that alone. Okay, next up we've got two different functions. This first set of brackets, that is my f of x. This is my g of x. So again, apply the product rule. So the derivative of the first is what I'm looking at. Well, the derivative of 3x, or x to the third, is 3x squared. The derivative of 4, that's gone. Times, leave the second thing alone. Plus, and I'm going to have to go underneath again because I have written too big. Leave the first one alone, x to the third minus 4, and take the derivative of the second. So derivative of 2, that's gone. Derivative of negative 3x, that's just negative 3. And again, I could distribute pretty quickly and go 6x squared minus 9x to the third, and then distribute quickly here. We've got negative 3x to the third, and we've got positive 12. Like terms would be the third power right here, so negative 12x to the third plus 6x squared plus 12 is what I get right there if I want to combine all those like terms. And it's always a good idea to practice with that. Now, this next one is just showing how to do multiple ones. So if I have 3 different functions, so f, g, and h, if I can identify 3 different functions being multiplied, well, I'm going to basically follow that same idea. You could do it with 4 things being multiplied, 5, 6, 18, it doesn't matter. You're going to take the derivative of the first, leave those 2 alone. Then you're going to leave the first one alone, take the derivative of the second, leave the last one alone. You're just going to take one derivative at a time and leave the others alone. So you would just take one, then take that one, and then take that one, and the other 2 functions that were there, leave it. So that's how you would do multiple pieces. One more example to do. The position of a particle is given by this function right here. Find the acceleration. So position, then comes velocity, then comes acceleration. So I'm about to have to take 2 derivatives to get down to acceleration. So first derivative is going to get me to the velocity. And this is a product rule. So f of x is this one, g of x is that one right there. So derivative of the first, t squared, that's just 2t. And then 4t, that's 4, so I have a minus 4. Leave the second one alone, that's cosine t. Plus, leave the first one alone, t squared minus 4t. And then take the derivative of the second. So derivative of cosine is negative sine t. Okay, from here, I could distribute and get a whole bunch of product rules, but I'm actually going to just leave it here, and I've got 2 separate product rules that I'm going to do. So acceleration is the second derivative, so I have to do derivative of this. So I'm going to take the derivative of this, and there are 2 things happening. I've got 2 functions, so I'm only focusing here. Derivative of 2t, that's simply just 2. The derivative of negative 4, that's 0, it's gone. We took the derivative of the first, leave the second one alone, it's cosine t. Plus, now let's switch the order. Leave the first one alone and take the derivative of the second one. Well, derivative of cosine is negative sine. So there we go. So now I've dealt with the product rule for here. But now I have to do plus a second set of product rules. I have this one and I have this one right here. So another set of product rule. Take the derivative of the first. Derivative of t squared is 2t. Derivative of negative 4t is negative 4. We did the derivative of the first, leave the second alone. Plus, now switch your order. I'm going to have to write smaller. We have t squared minus 4t times derivative of negative sine is negative cosine. So now I found the second derivative of that position function, and I had to go through 2 sets of product rules. But keep reading. It says find it when it is at pi over 2. So I'm going to simply go in and I'm going to substitute pi over 2 into each of these. So a at pi over 2. So we have 2 cosine pi over 2 plus 2 times pi over 2 minus 4 times negative sine of pi over 2 plus 2 times pi over 2 minus 4 times negative sine pi over 2 plus, I'm running out of room, we've got pi over 2 squared minus 4 times pi over 2 times cosine, I'm going to write really small, we've got negative cosine of pi over 2. Hopefully you wrote that in. I have run out of all this room. But let's think about what is cosine of pi over 2. Well, that's the position up here. So that's 0. So this right here, let me get just something to write on underneath here so we at least have somewhere to write. So 2 times cosine of pi over 2, well, that's 0 because cosine of pi over 2 is 0. Then I move over here. Well, 2 times pi over 2, that's going to be pi minus 4 times sine of pi over 2. Remember, that's up here. The sine value is 1, so negative 1 is what I'm about to multiply here. Plus 2 pi over 2, that's simply just pi, minus 4. And we just talked about this. That's negative 1. It's the same one again. And then right here, pi over 2 squared, well, that's pi squared over 4, if we square both of those, minus 4 times pi over 2, that would be minus 2 pi. But then we're going to multiply that by negative cosine pi over 2. And cosine of pi over 2, well, that's 0. So really, this actually didn't matter at all because it was just times 0 there. So now this is just what I have to worry about here in the middle. So if I distribute the negative, that's really a negative pi plus 4. This is a negative pi plus 4 when I distribute the negative 1 to both of these. So I have negative 2 pi plus 8.